Good evening, ladies and gentlemen. Good evening, good evening, good evening. Yes, thank you. Ransom Monica, you are there with me. It is all wonderful. I hope you're all ready and we can move on. I hope you're all ready and we can move on. I will start off from the beginning, where we, not necessarily where we left off from after the assignment workshop. I'll start off from way back then, just to cover all concepts that you may expect to be in the examination room. This is hoping that everyone has got a tutorial letter, the examination tutorial letter. If you don't have, please download one and let it guide you through your study. One moment, please. Thank you so much. I was blocking some sound coming from some other place. Yes, please do download your tutorial letter and use it to guide you through your studying. It is also prudent for us to mention that we need to have the A calculator. We have recommended the Casio FX82 ZA Plus, which is currently available, and be able to familiarize yourself with your calculator so that you will be using the same calculator in the examination room, and you can definitely operate it on that particular day. It does not help at all to go in there with a new calculator which you have just got hold of on that day, because that in its own self is a recipe for disaster. It is a recipe for disaster. Once you're prepared and you're able to work through the concepts using examples given in the learner guide, the learner guide is a very good study aid for you. It is a very good reference text for you to work from. The examples in the textbook are at times quite pitched at a higher level, more intricate, more complex, and some of the concepts contained in the examples we do not happen to cover in our syllabus. So therefore, rely on the learner guide to make you walk through the module much easier and much more clearer. That will be a very good starting point and a continuous point, so to speak. So therefore, take note of those things and be good. And once you've done practicing with the learner guide, which will work through examples relating you to particular points in the example, as well as linking it to the formula and where you get the variables to, or the quantums to substitute in the formula. That should be much good practice and exercise. You then use the past 3 examination papers that are on eLearn. If you can work through those as well, comfortably and without referencing to the guidelines or to the memorandum, then you should be ready for the examination. You should be able to walk into the examination and pass the examination. Yes. Our syllabus is in 4 parts, 3 parts. We have got a part where we talk of presenting data, and then we do describe our data, and We do make inferences or we conclude from observed scenarios, and then we end up forecasting. These are concepts that are very good in marketing or in management in general. We need them to be able to make decisions in management spectrum. We walk through all those as we prepare for the examination. I was dilly-dallying and shilly-shallying, hoping that the attendance is going to increase. However, it looks like we are stable at that number now. Yes, let me walk through. Statistics is the science of converting data into information. That information we need so much to make decisions in any management scenario. Therefore, we use statistics to manipulate observations from the environment for them to make sense to us. How do we do that? We do that using a number of facets. We can use tables to do the conversion. We may also use graphs, and we may actually use descriptive measures to get there. And when we're talking about the essence of statistics itself, it is concerned with the collection of data, presentation of data, analysis of data, and making conclusions from the information so generated. Tabular presentations will normally take the form of a frequency distribution table. The table that is on your screen now is a frequency distribution table indicating categorical data, data classified in categories: enjoy, read for entertainment, just throw away, hate. What is happening here is that a survey was carried out in Cape Town, and this survey was measuring the attitude of respondents to mail order catalog method of marketing. And we then found that the number of people that enjoyed receiving these mail order catalogs was 156. Those who read for entertainment, 234. Those who just throw it away or throw them away is 144. Those who hate the process of this receipt and sending of the catalogs, 66. In total, 600 people were surveyed. 600 people were surveyed. The data has been presented, and this follows collation. And the data now makes a bit of sense because you can see that most people read for entertainment, and least people hate the process. So yeah, it is still a good way of doing it because information is going to be disseminated. You can standardize that by using relative frequencies, where you relate the total or the frequency of that particular category to the total frequency. The frequency for enjoy is 156. If you divide that by 600 and multiply by 100, you're going to get 26%. We will get 26%. And that being done, in percentage terms, standardize the data, you can now and you may now see that coming out much more clearer. And besides tables, we can also use pictograms like the pie chart. That in its own self will actually even show it much better, but the pictogram is, as a pie chart, is a bit tricky because If the segments are a bit too close, then you will not clearly see the difference in terms of who and which category, um, how it behaves as compared to the other categories. So, yes, it's good for smaller, well-defined categories to use the pie chart. However, it has got those limitations that you to see. And of course, yes, if it is presented in color format, then yes, it becomes much more clearer. But if it is in black and white, then of course you need to be able to, if you're limited to the two colors available, so to speak. You may use simple bar charts to present categorical data. This is much more clearer now because you're able to compare, and those horizontal bars do show it out to you very, very clearly. May I mention here that if you're going to present data in any one of these forms, please be very clear that you must always have a heading. Always have a heading and label your axis. The y-axis, which is the vertical axis, will always reflect the frequency, and the x-axis, which is the horizontal axis, will always represent the categories or the classes or the groups in which you have placed the data, the bins concerned where you place that data. Always remember that the frequency goes on the y-axis and the categories go on the x-axis, which is the horizontal axis. Label those and make sure that when you subdivide your axis or you graduate your axis, you graduate them regularly. As you can see from 0 to 250, those are regular demarcations from 0 to 50, 50 to 100, 150, 200, 250. That is, and that will reflect a much better perspective, which is uniform. And we also have demarcated the categories, space them evenly as well. There is a lot of meaning that goes into that when you are talking about statistics and the reading of graphs. Besides the frequency distribution table, you can also present your data in tables called the contingency tables, which reflect more than two variables. It is still the same mail order catalog survey, but now we are saying how many people do use the catalogs or respond to catalogs, or they are exposed to catalogs in any way, living in houses or living in flats. As you can see, where we say enjoy reading or receiving and reading the mail order catalog, it is 102 for guys that stay in houses and 54 for those that stay in flats. That then specifies perspectives for us to be able to be directed in our marketing practices or marketing activities as to where exactly may we go, who stays where, who does what, when, and that is a contingency table because we are now reflecting more than one variable in the table. The total will still remain the same, and the totals for the two variables will add up to the grand total 600 as well. And these contingency tables, we do use them as well when we talk about basic statistical concepts. Later on, when we talk of probability, when we talk of basic probability concepts. Because we have shown two variables, that is respondents living in houses or dwelling in houses and those that dwell in flats, we may want to present this in a graphical format. What we see here is the component bar chart. The component bar chart, which tells you that as you look at the key The darker shade is respondents that dwell in houses, and the lighter component of the chart is those that dwell in flats. And therefore, you are able to say most of the people that read the or will enjoy the catalog will be in houses, so to speak. And this may not necessarily be the best way of comparing the two variables. The multiple bar chart is a much better way of comparing where your two bars are going to stand in juxtaposition. They may be a better way of comparing the two variables that you would have. We were talking about categorical data. Categorical data is specified in classes that will apparently be discrete, where we are able to say how many enjoy. There is enjoy, there is read for entertainment, you can do. However, it is only because our categories are few. Our categories are few, or rather our range is small. When the range becomes much bigger, for instance, in another study, we are looking at the available office spaces in Cape Town, available office space in Cape Town, and this could be any size. It can be any size. And because it can be any size, it will range from 115 square meters to 204 square meters, quite large. Therefore, with that large range, it will only be helpful for us to group that data. We will group it in groups of 115 to 129 with a class width of 15, with a class width of 15, where the bin contains 15 observations. No, it will contain a range of 15 in terms of the observations that go into that bin. However, that must not be confused with the frequency. The frequency is then the occurrence of office space that is within that bin or that class or that category. So therefore, that is group data. And once we have grouped the data, please note that the meaning of this data then does get lost. You've got 5 units that have been observed to be in the category 115 to 129, or rather we've got 5 office spaces identifiable between that 115 and 129. How big are they? We don't know. That data gets lost when you group the data that way. However, it is a good way of presenting data as well, and we do know that the number of classes that you are going to use must, be reasonable, so that you do not further find no reason why you've been grouping. The more the groups, less productive the process becomes. So therefore, keep your groups between, say, 3 and 8. Keep your groups between 3 and 8. It will make much more sense. Yes. So that is those groups, and therefore we would love to know how we do present that or represent that information in graphical format. The most apt method of doing it is using a histogram. That is the most relevant method of presenting that data in a graphical form. However, it does not mean that you cannot present it in any other way. You can also present it in a bar chart format. You can, where the bars are different from the bars that you see there, which are touching each other, for lack of a better word, which are hugging each other, which are close to each other, no spaces in between. Please watch out for what is in your textbook. It might be misleading, where there is space in between. I suppose that was a graphical design era histogram does not have spaces in between. What have spaces in between will be your bar chart. So the most common way of presenting data that is grouped is by using the histogram. But I'm saying to you, and we've seen a lot of questions in past examination papers where, true to book, there's been instances where we've asked to draw a bar graph to represent that data. Not only in the exams as well as in the assignments. We've seen that happening. It is also an acceptable way of presenting group data, so to speak. So some textbooks may differ in the sense that they will let you know that for group data, it's always the histogram. Please have an academic open mind towards it, because these things will be presented differently by different authors. As well, your frequency must always be on the vertical axis. Number of office blocks, that is what we were talking about, and your categories or classes are on your horizontal axis, which is the x-axis. Always, please, always. Definitely in the examination, you're going to be asked to do graphical presentation. We don't know which one, but if you do get asked to do that, you should be able to put your, or represent your frequency on the vertical axis and your categories on the x-axis. When you get to determining the classes in your examination, you will be given the classes. Excuse me. You'll be given the classes, so you don't have to worry about how those come about, because we will give them to you. The whole point is, if we allowed you to use your own classes, surely there will be as many memoranda as there are students that are writing that examination. So to be able to standardize things, we give you the classes, and we may want you to work out some few things here and there to then get it right, so that we can see that you know what this concept is all about. So yes, you will, yes, be careful whether it's a bar chart or it's a histogram that the examiner is saying you must use to represent the grouped data. Once more, have your heading, label your axes, make sure that they are graduated regularly, they are divided regularly. Notice that the first office block bar 114.5 to 129.5 does not start at 0, because 114 is not 0. That is the reason why. So yes, do leave some space there, and that should be well and good. That should be well and good. Over and above presenting our data in the form of frequency distribution tables, contingency tables, and graphs, we may find ourselves having carried out surveys, collected data, having to describe that data, and this is categorized in your syllabus as exploratory data analysis. And we use measures of position, measures of location. These measures of location will be the mean, median, mode, quartiles, and many others, but those are the ones that we do focus on when we are talking about our syllabus. We also do get dispersion measures. Dispersion measures. These will be your range, interquartile range, variance, standard deviation, coefficient of variation. And measures of skewness, which will then determine and tell us how the data behaves around the measure of central tendency, or measure of location. That would have used either the mean or the median or the mode, how it is dispersed from that measure. And this does indicate to us the extent to which we can rely on that data, the extent to which we can rely on that data set or that survey result that we've got. Let's talk about location measures, the mean. Ladies and gentlemen, you will be given a data set, and this data set you will be required to use. The one that we have in the example there is an ungrouped data set. If you do get observations coming from the environment, raw as they are ungrouped. The first thing that you do when you get this data is to arrange them in ascending order. We call this an array, from the smallest to the largest. Do that before you can do anything. If you are going to be calculating measures of position, you need to arrange your data into an array, your data in ascending order, because that is what is required of you. And it is before you do any calculations whatsoever. The mean is your common average, what we always refer to as what is the average this, what is the average that. On average, what is that? That is the mean. That is the measure we are talking about there. A study conducted on a marketing student showed that the following traveling times in minutes to get to college over 10 days were observed. On the first day, 18, 26, on the third day, 15, and so on and so on. So yes, arrange that into an array from the smallest to the largest. Our sample size is reflected as n. N is the symbol for the sample size, number of observations in a sample, n. And the formula is summation x over n. That will be on your formula sheet, which you are going to be given in the examination. Go to eLearn, download one, familiarize yourself with that formula sheet. You will get exactly that formula sheet that is on eLearn in the examination. So get used to it. Be able to understand which one is and which one is used to calculate what and what those symbols stand for. So, summation x means sum up all the observations. Divide by n, divide by the number of observations. There are 10 observations. So, once you have summed up those, they add up to 169. And that becomes 169 divided by 10. And that is going to be 16.9. You would always be advised to interpret your descriptive measures. On average, it takes the marketing student 16.9 minutes to get to college in the morning. So you would know that on average you're going to take 17 minutes. Therefore, yeah, you know, how do you prepare, what time do you wake up, and what to avoid, and what route to use if you should make it in time. Let us now look at the grouped data mean. That is the ungrouped data. When you have grouped the data, you've got traveling time 1 to 10, 3 times, or 3 of the days in the 10 days, the student travels to college in between 1 to 10 minutes. And 11 to 20, it's in 4 of the days, and 21 to 30 is in 3 of the days. All right. So that is your frequency, the number of days which students take to travel to college within the classes or the groupings of traveling time. All right. When you've got your frequency, you'd love to always check it out and say to yourself, oh, if I've got 10 observations, do my frequencies add up to 10? Wonderful. But you know what? When you've grouped the data, you do not have the individual observations anymore. They're lost. They're gone. They are not available anymore. Then, what is the best way of estimating them? The best way of estimating them is to assume that, you know what? If there are 3 observations between 1 and 10, I don't know whether they are all 1 or they're all 10 or they're all 8 or there's 6, 9, and 10. You don't know. So therefore, if you get the average for that class, the average for that class is called the class midpoint. What is the midpoint of that class? If the class is 1 to 10, the midpoint is 1 plus 10 divided by 2. 11 divided by 2 is 5.5. That's what you see there as the class midpoint. So if we estimate that the 3 observations are 5.5, because we don't know the exact observations, and multiply 3 by 5.5, we get a total of 16.5. So we have got a total now for the 3 observations. We do the same for the 4 observations between 11 and 20. The class midpoint there is 15.5, which is 11 plus 20 divided by 2. And 15.5 times 4 is equal to 62. The class 21 to 30, there are 3 observations. And the class midpoint is 25.5. 21 plus 30 divided by 2 is 25.5. 3 times 25.5, the total is 76.5. So we sum up, we add up those. 16.5 plus 62 plus 76.5, total is 155. So that is your summation fx. Summation fx. N is the total of the frequencies, number of observations. So 155 divided by 10 is equal to 15.5. The accurate one is the 16.9 that we got previously. 15.5 is the estimated one because we did estimate observations to be at class midpoint. So therefore, that is your grouped data mean. The mode. The mode is the most frequent observation. The mode is the most frequent observation. So what we do is we look at the data set, which is the most frequent, 17. That is the most recurrent observation. So it means that for most of those days, the student takes 17 minutes to get to college, which is almost next to the 16.9 that we got for the mean. Group data mode, you may want to identify the model class. The model class is the class which has got the highest frequency. It is the class with the highest frequency, which is 11 to 20. Once you have your model class, use the formula group data mode is equal to the lower class boundary of the model class plus class interval or class width Frequency of the model class minus frequency of the class smaller than the model class divided by twice the frequency of the model class minus the frequency of the class smaller than the model class minus the frequency of the class larger than the model class. The frequency of the class smaller than the model class is 3 because the frequency of the model class is 7. The frequency of the class larger than the model class is 10. Sorry, I'm talking about the cumulative frequencies there. Let me redo. The frequency of the model class is 4. The frequency of the class smaller than the model class is 3. That is the class 1 to 10. And the frequency of the class larger than the model class is 3, which is 21 to 30. Rosan is asking a question, do we get the tables as well? Which tables, Rosan? The frequency distribution tables. If it is that, yes, you may, or you may have to create them. But you'll be given the classes. No, those tables you don't get. I'll get to that. Those tables you won't get, I will get to that. That's okay. I know you are saying you are basically worried about the examination, but relax, and remember, you know everything that's going to come in the examination. Because you've got a tutorial letter, everything is detailed for you. You know all that. The median for ungroup data, our data is already in ascending order. And the median is the value that divides the ordered data set into 2 equal parts. Calculate the position, always. Always calculate the position. N plus 1 over 2. 11 over 2, 5.5th position. Meaning that the median value is between the 5th and the 6th observation. Exactly halfway in between, because it's 5.5. So you take the 2, it is 17 plus 17 divided by 2, which is equal to 17. Therefore, in half of the days, the students get to college in less than 17 minutes, and in the other half, the student gets to college in more than 17 minutes. That is your median. That is why I said to you, you need to always order your data set from the smallest to the largest. In terms of the group data median, you are talking of identifying the median class. Yes, the median position is n plus 1 over 2. If I may say something about the median position, I have always said that your textbook says for an even data set, use n over 2. For an odd number data set, use n plus 1 over 2. To me, it will be much more sensible to always use n plus 1 over 2, because n plus 1 over 2 will always tell you that the median value is between a particular observation and another observation. Because if you say 10 over 2 is equal to 5th position, the value in the 5th position is not the median. And then Trevor Webner tells you a story. Yeah, then you take this and you do that, and then you take this and you do that. The story is very long. However, if however you are very comfortable with that method, it's fine. But for me, n plus 1 over 2 all the time will be the right formula to use, because it specifies to you where exactly in the ordered data set you are going to find your median value. It does that. So, having decided that your median value is the fifth or 5.5 position is located there, you then do your cumulative frequency less than, meaning that you accumulate your frequencies from the top. 3 plus nothing is equal to 3. I'm looking at the last column. 3 plus 4 is 7. 7 plus 3 is 10. And we see that the position 5.5 is in the 11 to 20 class. So that's your median class. And we use the formula, group data median, lower class boundary of the median class, plus class width, multiplied by number of observations over 2, minus cumulative frequency less than of the class smaller than the median class, which is the class above the median class in the frequency distribution table, divided by the absolute cumulative frequency of the median class, which is the 4, which is that 4 there. And you get 16, and therefore you know that in half the time, students get to college in less than 16 minutes, and in the other half of the time, the student gets to college in more than 16 minutes. Quartiles. Quartiles will divide your data set into 4 equal parts. Again, they are position measures. You need to calculate the first quartile position. It is n plus 1 over 4, 2.75th position. It is between the second and the third observation. And the second is 8, the third is 10. Therefore, it is the 8, which is in the third position, plus the difference between the second and the third multiplied by the residual, which is 0.75. It is in the 2.75th position. Therefore, you are saying it is 8 plus, because it is 3/4 way away from the second. It is 3/4 way away from the second. Hence, you are looking at the difference between those two and wanting to position it accurately. That becomes 9.5. Interpret that in 25% of the time, the student gets to college in less than 9.5 minutes. And in 75% of the time, the student gets to college in more than 9.5 minutes. We won't bother with the middle quartile because that is the median. Upper quartile, Q3, would be 3n plus 1 divided by 4. These formulae you won't be given in the examination. You need to know them. You need to know the position formulae. You need to know those. They are not given to you in the examination. You must know them. And the process will be, yes, it is in the 8.25th position. So therefore, it is between the 8th and the 9th. 8th observation, 24. The 9th, 26. So it is 24 plus the difference between 26 and 24, which is 2 multiplied by the residual, which is 0.25. Therefore, it is 24.5. Interpretation. 75% of the time, the student gets to college in less than 24.5 minutes. And in 25% of the time, gets to college in more than 24.5 minutes. Jessica, where can I find the tutorial letter, please? Yes, Jessica, it is on eLearn. Thank you, Monica. It is on eLearn. Dispersion measures. Variance, standard deviation, coefficient of variation. Remember, we said the range as well. But that's the difference between the largest observation and the smallest observation. And the interquartile rank will be the difference between the Q3 value and the Q1 value. The variance is the average squared deviations from the mean. So you get your mean, find the deviations, square those deviations, sum them up, divide by n minus 1. You've got your variance. The standard deviation is the square root of your variance. In this case, it is 7.19 minutes. Coefficient of variation, it is the standard deviation divided by the mean multiplied by 100. It's expressed as a percentage. Therefore, we do know that our standard deviation is 7.19 minutes. Our mean was 16.9. Multiplied by 100 is equal to 43%. So that data set varies to a degree of 43%, which is fairly large. The data may not be relied upon. It's got a very large variability. Therefore, it has got small reliability. You would notice that if you look at the past 3 papers on e-learning, May 2016, October 2016, and May 2017, the examiner gives you the variance and says, work from there. That is the nature of the question that has been coming up all along. What does that mean? Maybe, maybe not, but habits die. I would think. For me, you know what? I would think it's standard. But you know what? Know how to do it. That's a good thing. Probability. This is the chance or likelihood of that something is going to happen. Because what types do we have? The subjective, where we're talking about thumb-suck intuition. We don't use that in statistics. Objective. Yes, it can be verified empirically. We go out there and we can prove stuff. And what is the notation? We can also define this as a ratio of 2 numbers. The probability of event A is equal to R over N. What does that mean? A is the event of a specific type. R is the type of outcome, or is the number of outcomes of event A. N is the total number of all possible outcomes. Probability of A is the probability of event A happening. And having got the notation, we can derive objective probabilities, and we can do it a priori, where the outcome of that particular event are known in advance. For instance, tossing a coin, it's either a heads or a tail, therefore we know that the probability of a head is 0.5, and knowing that is well in advance. Empirically, we go out there, we do our surveys, we get our observations, and we do our calculations, and we can be able to say, oh yeah, you know what? The chances of someone walking by and entering our shop to buy is this. We observed it over a month, and this is what happens. And we've got, we can derive them mathematically, where the pattern of events is known in advance, and we therefore use a formula to derive that known pattern. We apply our scenario to that known pattern. A probability value lies between 0 and 1. If an event A cannot occur, then probability of A is nil. And if event A is certain to occur, its probability is 1. The sum of all probabilities, of the probabilities of all possible events will always equal to 1 in any sample space. If we sum up the probabilities, they'll equal to 1. And we also must be aware of the complementary rule. If probability of event A is the probability of A happening, then the probability of event A not occurring is defined as the probability of not an A is equal to 1 minus the probability of A, which we know these two events are known to be in the same sample space. Using the complementary rule, we can, if we know the probability of A happening, get the probability of A not happening because we may not know that. Yes, marginal probabilities are probabilities of a single event A occurring only, and joint probabilities will be both events A and B occurring at the same time, and conditional probabilities will be event of A, probability of event A occurring given that event B has already occurred. And that example will explain that. When we talked about mathematical derivation of objective probabilities, this leads us to probability distributions. It leads us to probability distributions, where we will come across the binomial distribution and the Poisson distribution. These are discrete probabilities. There is the normal distribution, which is a continuous distribution. We will only use that in an application format, but not to work out the direct probabilities that will relate to its pattern. In a binomial probability, you are going to be given probability of two events. There will be a probability of success and a probability of an or failure. And once you've identified that, this question is a binomial question because of the probability of success being given. And this success relates, excuse me, the probability of success relates to the random variable under study. It relates to the random variable under study. It does not necessarily, it should not be taken literally as success. The formula to use is the probability of x occurring being equal to n combination x, p to the x, and q to the n minus x. In your textbooks, q is replaced by 1 minus p. 1 minus p is in the explanation there. N is the number of trials, that's the sample space. X is the number of successes, it is what you are calculating. N minus x is the number of failures, and p, the probability of success in one trial, and q is 1 minus p, as defined in your textbook. Let's look at an example. The marketing manager of a chain of pizza restaurants would like to know which areas of the business is more successful. Takeaways or eat-in? He hires you to do some marketing research. If there's a 25% probability of a customer wanting a takeaway and there are 10 customers in the restaurant, what are the chances that 7 of them will want a takeaway pizza? Good. What is the random variable under study? Takeaway, wanting a takeaway pizza. Wanting a takeaway pizza. That is the random variable under study. And it does say to us 25% chance that you may do that. So that is the probability of success. That is P. P is 25%, and 25% is 0.25. And what is the sample space N? It is 10. We are asked to calculate the probability of 7 out of the 10. X is equal to 7. N minus X, 10 minus 7, 3. P we said is 0.25. Therefore, 1 minus P is 1 minus 0.25, which is 0.75. We then substitute the formula. The probability of 7 out of 10 is equal to 10 combination 7, 0.25 to the 7, 0.75 to the 3. Take your calculator. Always in probability, set your calculator to 4 decimal places. It avoids complications in terms of getting very, very wild answers that you don't understand. 10 to the minus something something. Oh, yeah. Please do avoid that by setting your calculator to 4 decimal places. And you do this by looking at your second function, set up, fix, and then select 4. Good. Let's interpret that. Our answer is 0.0031, which is 0%. Therefore, there is almost no chance of 7 out of 10 customers wanting a takeaway from this pizza house. The probability is 0. There's a 0% chance that 7 out of 10 customers will want a takeaway. Poisson probability distribution. My formula is distorted. I know I promised last time to fix it. Yeah. It is distorted. I would love you to refer to your textbook and look at page 138. Look at page 138. The probability of x is equal to e to the minus lambda, lambda to the x over x factorial. A Poisson probability distribution will always be identified by the words average and PER. And x is the number of occurrences for which we want to calculate. E is a mathematical constant. It is there as well on your calculator. E to the x is a second function on your calculator. Of course, lambda is the mean or average number of occurrences in that particular question. An example, you are asked by the manager, same marketing manager of the chain of pizza restaurants, to do some more marketing research. On average, 5 out of 10 customers want a takeaway, and there are 10 customers in the restaurant. In this instance, what are the chances that 7 of them will want a takeaway? Yeah, we are talking about the same random variable under study, and the reason why we know it's Poisson is because they are giving us the average number of occurrences. X is 7, E is that constant 2.718, which is there on your calculator, and this practice is going to get you there. If you use the same calculator, you are going to practice enough to be able to ensure that you know how to use that. And yes, our lambda is the average, which is 5. The root of 7 customers out of 10 is equal to e to the minus 5 times 5 to the 7 divided by 7 factorial. The 7 factorial as well is there on your calculator. It's shown as a second function, x exclamation mark. X exclamation mark. And this time your answer is 0.10445. So therefore, in this instance, there is an 11% chance that 7 out of 10 customers will want to take it away. That is your Poisson distribution. If you look at all the past papers, definitely you are going to come across binomial and Poisson. You are well advised to know those. Now we come to another department of statistics, which is inferences, where we now make conclusions out of what we would have done. Look, we carried out a survey and we got a sample statistic. The sample says that this is what it is. Can we say the same for the population? If we can do that, we call that a point estimate. But if we can't do that, then it will be safer for us to be able to get a confidence interval. My formula might not necessarily be clear as well. I will refer you to page 181 in your textbook. Go to page 181 in your textbook. This formula uses the normal distribution mathematical formula to estimate this range, because we said it would be safer for us to create a range, an interval, rather than us pinpointing an exact result and say that what we found in the sample is the same as what we're going to find in the population. It's safer for us to say, okay, fine, yes, you know what we may find in the population will be between this and that. And we do this guided by some level of confidence. We'd love to estimate this at a particular level of confidence or create the intervals at some level of confidence. That's why we call them the confidence intervals. And where the population standard deviation is known, we use the formula mean minus z sigma over square root of n less than or equal to mu less than or equal to sample mean plus z sigma over square root of n. Let's apply that to an example. A survey of a random sample of 300 grocery shoppers in Kimberley found that the mean value of their grocery purchases was 78 Rand. Assume that the population standard deviation of grocery purchases is 21 Rand. Find the 95% confidence limits for the average value of grocery purchases by all grocery shoppers in Kimberley. N, sample size 300. X bar, sample mean 78. That's the average from this survey that we did. Population standard deviation, sigma 21. The z value would be given to you as a critical value. Jessica, was that you? Oh, no. Who was saying? Oh, that's Roseanne. Roseanne was saying that, will I get the tables at the back? No, you won't get the tables at the back because you will be given those values that you need to look for in those tables at the back. And these will be given to you as critical values. Critical values. So that's what you use in place of Z in that formula there. That's what you use in place of Z. What we are using there is the Z transformation formula in the normal distribution. In the normal distribution model. That's what we're using there. So, yes, you then substitute and you get your 78 minus 1.96 multiplied by 21 over square root of 300 less than or equal to mu 78 plus 1.96 21 over square root of 300 multiplied by that And then, yes, you now get your lower limit and your upper limit. The first part calculates your lower limit. The second part calculates your upper limit. Therefore, your lower limit is 75.62, your upper limit is 80.38. What is your interpretation? We are 95% confident that the true or the actual value of grocery shoppers in Kimberley will lie between 75 Rand 62 cents and 80 Rand and 38 cents. That is our interpretation. Now, that is confidence intervals with the population standard deviation known. It is known. Where it is unknown, where we don't know the population standard deviation, we may want to use the T distribution. It is the one that best estimates, our interval in situations where we don't know the population standard deviation. An example, a clothing store analyzed the value of a random sample of 25 credit card purchases. The sample mean was found to be 170 and the sample standard deviation was 22. Sample standard deviation. That tells you that you now need to use the T distribution. And the formula is on page 188 of the textbook. It's on page 188 of the textbook. Good. And therefore we identify them again as N being the sample size 25. Sample mean is 170. We've been told that from the scenario given, and our sample standard deviation S is 22, and the T value is also going to be given to you as a critical value in your scenario. So you will not have a need to look it up the other side. Yes, Monica, why am I saying that standard deviation is unknown yet it is given to us? Sorry, Monica, for confusing you. However, I am saying to you, in the first example we did, we were given the population standard deviation. The population standard deviation. If the population standard deviation is unknown, then we resort to using the sample standard deviation. The symbol for population standard deviation is sigma. The symbol for the sample standard deviation is S. And that is where the difference is between these two examples. You can see in the question there. All right, Monica, thank you. You can see in the example there that sample standard deviation is underlined, and there we did underline the population standard deviation. And we are creating these limits at 95% level of confidence. And therefore our T value will be given to us. We won't have to read it off from the tables. So we use the critical value that is given. We substitute. There is our lower limit, our upper limit. The interpretation is the same. We are 95% confident that the credit cards purchases will lie between 160, 92 Rand, 160 Rand and 92 cents, and 179 and 8 cents. That is our conclusion. Please be very careful about how to conclude. The interpretation of the calculation is very, very, very important. Yes. Hypothesis testing. At times you get people making claims. When they do make claims, it is incumbent upon us to test those claims, that we can be satisfied that what they are claiming is the right thing. When we do this, we are carrying out what we call hypothesis testing, because the claim is an hypothesis, it is a claim. It's not tested yet. It can't be a theory. We follow the 5-step process. Number 1, define hypothesis or formulate a hypothesis. There are 2 of them, the noun and the alternative. Defining these will be guided by the management question. The nature of the management question will determine how and which one we set up first. We then determine the area of acceptance and rejection. We compute the sample statistic using the formula at the bottom there. Z-calc is equal to x bar minus mu sigma divided by sigma over the square root of n. And then we compare the area of acceptance and rejection with what we would have calculated. And then we can conclude whether it falls in the rejection region or in the acceptance region. And then we draw our conclusions. When we do a hypothesis test, we test at a level of significance. The level of significance is related to the level of confidence. We either test at a 10% level of significance, which is related to the 90% level of confidence. Or we may test at a 5% level of significance, which relates to a 95% level of confidence, or a 1% level of significance, which relates to a 99% level of confidence. And those will be the values that, the Z values that will be associated with those levels of confidence and levels of significance. The Z transformation formula is what we use to calculate the Z-calc, because yes, we are converting or we are standardizing the observations in the environment to the distribution that we are dealing with. An example, the Grocery Retailers Association of SA believes that the average amount spent on groceries by Cape Town shoppers on each visit to the supermarket is 175 Rand. The average amount spent is 175 Rand. To test this belief, the association commissions market research in Africa to conduct a survey among a random sample of 360 grocery shoppers at supermarkets in Cape Town. Based on the survey, the average value was 182.47. Assume that the population of grocery purchases values is normally distributed with a standard deviation of 67.5. Once more, we are given a population standard deviation. Can Grasser conclude that grocery shoppers spend 175 Rand on average on each visit to a supermarket? Conduct a test at the 5% level of significance, and they would have told you, use a critical value of this, that, this, that. A claim is made, and then to accept or disprove the claim, you have to carry out a survey. You have to sample to get your own information. What you are being told the claim is as here. This claim is related to the population. What you are then going to survey will relate to the sample. Let us look at the solution. And I am now looking at your page 200 in the textbook. N is the sample size. X bar is the sample mean. Mu is the population mean. Sigma is the population standard deviation. Z is the critical value, plus or minus 1.96. Okay. Let's define the hypothesis. That's step number 1. The management question says that. Let's go back. It does say that this association believes that the average amount spent is 175. Can you conclude that it is 175? Which means that, are you sure mu is equal to 175? And because we are being told it is equal to, we use this management question to set the null hypothesis. Therefore, H0, mu is equal to 175. The alternative will always negate, will be the opposite of the null. H1, mu is not equal to 175. If it is not equal to 175, mu is either less than 175 or larger than 175. And that simplifies how you determine the area of acceptance and rejection. This is a two-tailed test because of either less than or more than. It then becomes a two-tailed test. So, step number 2, region of acceptance and rejection. You can either present it as shown in figure 8.4, figure 8.4 on page 203. Draw that distribution curve, have minus 1.96 on your left and plus 1.96, and say that region of acceptance is between minus 1.96 and 196. If it's less than 1.96, or if it's less than minus 1.96, you reject. If it's more than 1.96, you reject. The next step is to calculate the z-calc value, which is the sample mean minus the population mean divided by sigma over square root of n. And your value is 2.08. You now compare 2.08 to your z value, which is shown as alpha there. 2.08 is larger than plus 1.96. Therefore, we are going to reject. It lies in the rejection region. You therefore reject the null hypothesis because 2.08 is in the rejection region, is greater than 1.96. How do you conclude? You are 95% confident that there is not enough evidence to support the claim that has been made by the association. The evidence available may not support this, is not supporting this claim. That is your hypothesis testing. A tip for you. We're going to test the hypothesis. My advice to you is that always follow the 5 steps. No matter what the examiner is asking, it will fall within those 5 steps. You will lose nothing. It just maintains consistency. And then after that, you may number according to what the examiner is asking. Follow the 5 steps and you will be home and dry. We at times are asked to test for association or independence, where we are saying to ourselves, okay, you see drivers along the roads. What cars, or rather, is gender associated to driving a particular type of car? Do we normally get ladies driving bakkies? If there is that association, then we say, oh yeah, yes. If there's none, then we say, gender and type of car are definitely independent. At times as well, we may be asked to test for goodness of fit, which is what I have for you there. And we use the chi-square goodness of fit test. The chi-square goodness of fit test. I am looking for the, yes, I am talking about chapter 10. I am talking about chapter 10. Goodness of fit. I can see independence there. Yes, on page 282. Goodness of fit on page 282. All right. Having done that, we are saying that, can we exactly say that what we are observing now relates to what we normally know to be the norm? We want to confirm normalcy. We want to confirm whether what we are seeing is what is to be. What we are seeing is what is supposed to be. We therefore use the chi-square goodness of fit test. The formula remains the same, where we are saying the chi-square curve will be summation observed frequencies minus expected frequencies square the difference divided by expected frequencies, and you sum those up. There's an example. Metro Rail Commuter Service is studying the daily commuting patterns of workers into the Central Business District of Cape Town. A study conducted 7 years ago found that 40% of commuters used trains, 25% used cars, 20% used taxis, and 15% used buses. As a market in Metro Rail, you conducted a recent survey of 400 randomly selected commuters found that 135 trains, 115 cars, 96 taxis, and the rest will use buses. Test this at 5% level of significance. The critical value is 7.815. It's that. Okay. Now, what do? You have got to understand the data. According to your observations, you, from the scenario, are told that 135 people will use the train today, and 115 will use the car, and 86 the taxi, and remainder the bus, which is 54, total 400. And then you are told that, you know what, it used to be that so many years ago, 40% used the train. 40% of 400, which is 160, 25% of 400, 100, 20% of 400, 80, and 15% of 400 is 60. So now you've got your observed and you expected. You expect the observed to be similar to the expected, which used to happen, because you want to test for the fit between what you are seeing now and what is normally the case. So it is observed minus the expected. You square that difference, divide by the expected, and you sum them up, and you've got your total 9.956. Right. Your null hypothesis will always be commuting patterns today are the same as they were 7 years ago. You confirm the claim, and in the alternative, you refute the claim, you oppose the claim. And of course, yes, region of acceptance, you are saying that the critical value given, if what you calculate is going to be less than that, you accept, and if it is going to be more than that, you reject. The chi-square test is a one-tail test to the right, or it's a one-tail upper test always. So that's very clear. Less than, more than that value you get, then that's fine. So now, your calculation there gave you 9.956. Compare, it's more than 7.8. Therefore, you reject it now because 9.956 is larger than the critical value given. And true to book, we are saying to ourselves that we are 95% confident that the evidence provided does not provide any fit between what's happening today and what it used to be 7 years ago. Let's go into forecasting. Forecasting. We are talking about the relationship between two variables, X and Y. And this relationship is found by doing a scatter plot. A scatter plot which will tell us whether it is negative or positive, and it's normally linear because we produce a line of best fit. If it's linear, we have used the straight line equation. Y is equal to mx plus c. Then, now we say y is equal to a plus bx, or according to your textbook, y is equal to b0 plus b1x. With a formula for getting b1 and a formula for getting b0. We are told that music technologies in Durban has recorded the number of flat screen TV sold each week and the number of adverts placed weekly for a period of 12 weeks. They want to determine the relationship between adverts and sales. When they placed 4 adverts, they sold 26. They placed 4 the other week, they sold 28. And then they placed 3, they sold 24. They placed 2, they sold 18, and so on and so on. Now, when you get this scenario, they'll say to you, calculate the linear regression equation, which is y is equal to b0 plus b1x. You're going to get that data. The first set of observations, adverts, is x always, and the next one is y. The table could be presented horizontally like that. It may be presented vertically as well. Whether it's vertical or horizontal, you are still going to call the first one x and the next one y. In that event, we get to our formula and we realize that we are being asked to get xy, x squared. For B1, there is the formula, and we've got summation x, summation y, summation xy, summation x squared. We substitute those values into the formula. Once we have done that, we carry out the calculation and we get our B1 being equal to 4.37. We now use B1 to get B0. Summation y, you get from your table. Summation x, you get from your table. Multiply by B1, and subtract that from summation y. Divide by n, you get your B0. It is equal to 12.82. Always, ladies and gentlemen, specify that y is equal to 12.82 plus 4.37x. And you now have got that. The examiner is going to ask you to forecast. If you placed 10 ads or 10 adverts, how many sales of flat screen televisions do you expect? You then substitute x for 10, and you then get your y, which is 56.52. Therefore, yes, you are going to sell, if you place 10 adverts, you are likely to sell 56.52 TV or televisions. That is your linear regression forecasting. And then you will be asked to calculate, that or interpret, either calculate or interpret coefficient of correlation, which determines to you the strength of the relationship between adverts and sales. You use the formula R squared on page, it's not clear there, it is on page chapter 12, page 335. It is on page 335. R is equal to n summation xy minus summation xy multiplied by summation y divided by the square root of all those variables there. Yes, your table will give you those values. You will substitute into that equation and get an R value. You then say to yourself, the relationship lies between -1 and 1. Pearson's correlation coefficient is a value between -1 and 1. If it is negative 0.5, it is a moderate negative relationship. If it is positive 0.95, it is a strong positive relationship, meaning that definitely if you do advertise, you are going to generate more sales. That is the meaning of the Pearson's correlation coefficient. You realize that from the past papers, we've not been asked to calculate it, we've been asked to interpret it rather. So to interpret it, use that scale. Use that scale. Index numbers. We would like to forecast the nature of prices. What are they going to be? And it is the same way that we do forecast our inflation or calculate our inflation in the economics arena. And we may use a price relative or a quantity relative which calculates the price index of only one commodity. Price in the current period divided by price in the base period multiplied by 100 will give us the price index. If the price index is larger than 100, then there's been an increase. If it is less than 100, there's been a decrease. That example says to us, January 2016, 330 milliliter can of Super Cola sells for $9.50. In 2017, it sells for $12.50. Calculate the price index. So it is P1, the most recent price, divided by the older price, multiplied by 100, which is equal to 132%. Therefore, the cola has increased its price by 32% between 2016 and 2017. That is the meaning of that. And yes, we may not necessarily look at only one commodity. We may be asked to look at a basket of goods, and we do calculate the composite price index, either the last periods or the PASH price index. The last periods or the PASH price index. The last period price index will use quantities in the base year as weights, and the PASH price index will use quantities in the current year as weights. And those tables do show you how each one is calculated, summed up, and we do the divisions, and then we do our interpretations. The last concept is forecasting using your time series. And we can, when we talk about a time series, determine that a time series is affected by cycles, seasonality, irregular activities, and we can isolate each one of these and decompose them and be able to tell how that factor affecting a time series will develop over time or in that time series. In this example, we are talking about a trend. We will look at a trend of, and for insurance claims that were made between 2008 and 2011. 2008 and 2011. In the first quarter, 7 claims were done. Second quarter, 3. Third quarter, 5. In 2009, first quarter, 9, 7, and 9, and so on. The most important thing in this question is to be able to arrange that data into a format that will allow you to calculate the 3-period moving average. To be able to decompose a time series, you may use regression analysis or linear regression, or you may use moving averages. And you've got the 3-period, the 4-period, 5-period, and so on and so on. We want to be looking at the 3-period moving average here. And we've looked at our period. There is the year, period 1, period 2, period 3, 2009, period 1, period 2, period 3. Arrange them in that order progressively. And then you say to yourself, I must now calculate the 3-period moving total, which is centered because the total is always placed against the middle value. It's always placed against the middle value. 7 plus 3 plus 5 is equal to 15 placed against 3. You drop the top 7 and you pick 9 at the bottom. So now you say 3 plus 5 plus 9, 17, placed against 5, which is the middle value. You drop 3, you pick up 7, and so on and so on. Once you've got no dropping and picking up to do, you then say to yourself, all right, I've got my 3-period moving totals. Let me get the 3-period moving averages. You divide each one of them by 3 because you have been adding 3 numbers at a time. You divide each one of them by 3 because you've been adding 3 numbers at a time. You then get your average values, 5, 5.67, 7, 8.3, 9.3, 8.3, 8.6, 9, 10, 10. The question will be, describe the trend. We do see that the trend increases and then it drops slightly and it continues to increase. So generally, there is an increasing trend. So therefore, you can see that claims will increase in this company. That is the trend calculated. Ladies and gentlemen, these are the concepts that you may want to look at in preparation for the examination. I've got 4 attendees left. Any questions? Like I did say to you, the best thing to do is to ensure that you practice, practice, practice. Use the past 3 papers to practice. Thank you, Monica. I wish you all the best in your examination. Create confidence, and thanks for saying, you create confidence by going through those past papers. Use the learner guide. It is very helpful. It's got very good examples. It summarizes very well. It does that very well. Know your calculator and be accurate. You've got 3 hours to do those questions in. Carry out your calculations and go over them again. But even before you do that, you want to make sure that you are using the right formula. Substitute correctly. Don't be in a hurry to go through this stuff. Double check yourself. Extract your information from the scenario. Substitute correctly and punch your calculator accurately. Make sure you're punching the right button and have your answer. Check it. 3 hours is more than enough for you to get through the examination very, very comfortably. That is if you've prepared enough for the examination. I wish you all the best. And please remember, if you get stuck in any way, yes, you can see the answer on the memoranda that are posted on eLearn. If you want some explanation, do not hesitate. Email us or do call me or email me directly. You will be very much in good stead. Academic, undergraduate at IMM, ESM.ac.za. You will do get the help you need. Thank you so much. Have a good evening.